Hello, welcome to episode 115 in this series where I am programming an NES game tonight live on Twitch. Let's get started. In the last episode, we got sound working. You can hear the beeping in the background very faintly here. And that was just some code we added to make the game play a little pulse wave tone every 30 every 30 frames. I don't remember now. Hey Banchiku, how's it going? So let's play around with some of the other audio channels to hear what those sound like and see how we can make some cool noises with those. And then maybe we can combine a couple together and have a couple pitches and start to talk about how we're going to make either I don't know if we're going to build our own sound engine. There's part of me that wants to do that because it would be fun, but at the same point, it's a lot of work, and there are some good sound engines already out there. Banchaku says don't. Well, yeah, I mean there's GG Sound, which is a pretty good one. There's Pentley and what's the other one that Famitone. So those are just three that I can name off the top of my head. There are, I'm sure, some other ones. I think there's a separate fork of Famitone that people use as well. It can be a project as big as the game, so it may not be worth it. Yeah, I know, and so part of what I was thinking was if I could limit the scope of the music to something manageable, I could actually build my own, but I don't know. I'm not 100% sold on that. I think it's going to be a lot of work, and we've already spent a lot of time on other stuff that has taken more time than I expected. So I think maybe what we'll do is we'll kind of figure out how all this stuff works, and then move on to using a sound engine just so that we can make progress without having to build our own from scratch there. But I don't know. We'll see. It's like where is the cutoff of what we're going to do from scratch? I don't know. How are we going to make the music with your one, which becomes the main issue? Yeah, no, I know. I mean, the thing. So what I was thinking about is if I made my own sound engine, I would keep the functionality really simple in terms of what it could actually do. I mean, I'm not a huge fan of NES music that goes crazy with things like arpeggiated chords, which is like I think that's kind of a more demo scene thing. But I'm thinking I could probably get away with implementing some very basic musical structures and notes and stuff, but I don't know. I have to read up a little bit more on what's involved and figure out what I want the music to sound like in the first place. So for now, we're just going to mess around with it and see what this sounds like and see if we can put something basic together, and then I'll think about it and come back to it and see if we're going to end up using anything that's out there besides my own. So last time we did the pulse wave, the two pulse waves are, I think, identical. You can see they've got the timer, the length counter, the envelope, and the sweep. Triangle is a little bit different. It does not have a volume control, so you can only do the timer, the length counter, and the linear counter. So let's play around with that and see what that sounds like. Yeah, that's a good point, Monshiku. I could just use GG sound to, make it work, and then come back to it and add my own afterwards once the game is more functional. I don't know. I'm not settled either way right now. So this is where we're setting the. Okay, cool. So this is where we're actually controlling the pulse wave. So let's change this to 400B. And that's the triangle wave now. We need to change where we're setting up the pitch settings as well. So in the pulse, 4002 is the timer low, and 4001 is, let's see, enabled period negate, okay, and shift. And then timer high, okay, 4003 is what I wanted. So length, counter load, and timer high. So I'd set the value to FD for the frequency. So let's take a look at, for the triangle, how that differs. So looks like it's actually the same mostly. The only part that's different is the first register, 4008. Or not the only thing that's different, but the main thing that's different is this first register. It depends who will make the music. Well, I intend on writing the music. I've got experience writing music. I play music, so that was my plan. We don't have to. I don't want to spend too much time, but if you go to this page, I've got a bunch of music here that I've written. So I don't know what's a good example. Let's do one that's actually sort of NES sounding like here. So, I mean, this wasn't done on the NES or with Family Tracker, but it's, similar to what the NES can do. I had actually started rewriting it in Family Tracker, but didn't really get that far. Here, we can bring this up. Family Tracker. I think I've got this on here. Not finished, but anyway, that was the idea of sort of porting it to the NES just to see what it would sound like. If you know how to use Family Tracker, then keeping in the limitations of Family could give you a lightweight solution for music and sound effects. Yeah, I mean, that's the thing. It's like there are so many good solutions out there. I kind of, on the one hand, I want to play around with it, but I also want to finish the game sometime this year. So adding on the work of building another sound engine seems maybe unnecessary. I don't know. So let's take a look at this triangle wave thing here. So we've got the length, counter, halt, linear control, counter, load. Triangle wave has 32 steps that are output a 4-bit value. Linear control will silence the channel after specified time with a resolution of 240 Hz. It shares a control bit with the length bit. which means that they are always enabled at the same time. The pitch of the triangle is 1 octave above the pulse channel with an equivalent timer. Okay, so it's going to be an octave higher. You know, my project I figured out quite fast. It'd not be worth it because some sound engines exist. I may play with it later too. Yeah. Well, you posted those videos of the John Wick thing that you were doing. That was pretty cool. It was neat to see that compared to the project that it was based on. Well, yeah, I know that's just the one of them. I'm not talking about the other one. All right, so let's see. Linear control counter. I have no idea. Let's give a good example of how this would work. Sequencer is clocked by a timer whose period is 11 bits, formed by high and low timer +1. Counter time. The counter counts t minus 1 to 0, clocking the waveform generator when it goes from 0 to t. Unlike the pulse channels, the timer takes the rate of the CPU clock rather than APU clock. The following relationships hold. Unlike the pulse channel, triangle channel supports frequencies maximum. Note that writes to both B8 and B will set the reload and cause reload of linear counter. Sequencer is clocked by the timer as long as both linear counter and link counter are non-zero. The sequencer sends the following looping 32 sequence of values to the mixer. So write 80 to 4008. So let's take a look at why that would be. So 80 would set this to 1 and the rest to 0, because that's the counter reload. Okay, so I guess we're just setting the counter because there is no volume. So basically, so I expect what's going to happen is this is going to sound weird because we're basically just setting this. We're just resetting this value over and over again. It's probably just going to make like a horrible sort of noise or pitch. It's not going to do what's expected with the logic we have now because, well, maybe not. Maybe because it's resetting the counter, it's not doing anything. Let's see if we just set it once here. So let's get rid of... get rid of all of this. Oops, not all of that, just the pulse counter stuff. So let's comment that stuff out, and then where's my other audio stuff? Oh, why didn't I change that? So 400A and B. Let's see how that sounds. That should, oh, you know what we need to do? We need to set 4008. Let's set it to 8.5. Okay, so that's doing a constant sound, and that's because, like I was saying, because it has no volume, it can't do the pulse, so it can either be on or off. So we could do something where, if we go back to our pulse counter, we could say, let's change this logic here. Let's do something where, let's say if we compare it and it's below then what we'll do is we will, if it's less than 0, what we'll do is we will turn off the sound. So we'll load A 80, store A 4008. Otherwise, we get rid of that. So this is where we're resetting the pulse counter, and what we'll do is we'll load 85 and store it into 4008. So we're basically just going to reset it to make a sound. So it'll be similar to before, but instead of being like a fading pitch, it's going to just be on and then off, maybe. No. Let's see. Why is that wrong? That's turning it off. Or making it silent, rather. So while it's compared to C3, branch not equal to here, decrement the counter, load A, compare to that, compare to 3C, branch if it's greater than, no, what is that? When you're comparing 3C to, I don't remember what these values are in decimal. And for the purposes of this, my brain needs to know this. So if it's, compare it to 60, and if it's greater than, if the value in A is greater than 60, it's going to have the carry set still. So it will skip this part. We want to do the other way. No. I think this is just not. Hey, Paul. Yeah, scrolling is working well. I don't know if I'm working on my own audio engine so much as I'm just trying to understand how audio works. We were having this discussion before, Bonchaku and I, that there are some good sound engines out there already, so it may not be worth it at this point, just in order to get the project to progress, right? Just better to have something working, and then we can circle back and implement that if we want to. I kind of want to do it more from a curiosity perspective than anything else, but we'll cover sound here for a little bit and then kind of move on to some more gameplay stuff. I figured it'd be fun to play with something a little bit different than what we were doing before, just because we spent so much time with the scrolling stuff not working. Here, let's add so instead of doing this, let's use 8.8 because I'm going to flip the bit. We're going to alternate the bit, store X into pulse value. Okay, so pulse counter. So let's just decrement pulse counter and then load a pulse counter. Branch not equal to here. And if it's equal, then what we'll do is we'll load pulse value, exclusive OR that with 8, and then store it into pulse value, and then store that into 4008, which will set the counter again, and then load a pulse counter. No, load a, what is it, 3C, and store that into pulse counter. All right, let's see if that works. There we go. Right, yeah, it is. Pretty easy to drop an existing engine in. Yeah, it is. But as Banchaku just responded to you too, the sound engine in and of itself is a totally separate project that can take forever. I was having enough time spent on this whole scrolling thing, and it's kind of nice that this is working, although the collisions are not properly being detected. I need to get that fixed, but the fact that it now will alternate between the map that's pre-drawn and then this repeating single meta tile will give us some options in terms of how we want to progress the level, and not taking up too much space on the cartridge for each level. And we can kind of play it by ear depending on how we want the level structure to work. We can do different things, but so you can see here it repeated properly back to the beginning of the level, which is just this little snippet of meta tiles that I built in Tiled and exported with the asset tool once this loads. So yeah, it's the same level layout here, and it's got an enemy placed there. I gotta fix that the enemy is gonna show up here at the very top just because the overscan is turned off. But the scrolling is working nice and smooth, and you don't see the attribute updates or the tile updates, which is exactly why we switched over to the horizontal mirroring instead of doing the vertical mirroring that we were doing before. So, but again, I kind of was excited to do something a little bit different for a little bit. So we got triangle wave working, so that sounds cool. So it sounds like we can do some stuff here with the triangle wave to make it sound a little bit different. So that was with that counter. If we do, if we make this 8-4, Eeyore, nope, that's arrow, Eeyore, make that, oops. See if that sounds any different if we do 4 instead of 8. Let's see. So that sounds basically the same. How can we length counter load? Let's try messing with that. Right now it's not doing anything with the upper bits. Let's make this 8. Let's see what that sounds like. That sounds pretty much the same. Really getting much difference out of that. Low timer. I mean, we can change the pitch. I was length counter load. What does that actually do? Linear counter, length counter. There's no volume control. The waveform is either cycling or suspended. It includes a linear counter, an extra duration timer, or higher accuracy than length counter. Includes a timer, a length counter. Length counter provides automatic duration control for waveforms. Once loaded the value, it can actually count down when the length counter halt flag is clear. Oh, I see. So that, as opposed to me setting it manually to clear out, it's an actual length that it counts down. Oh, and the pulse has that too. That's interesting. So that's how you would set the duration of the note rather than having to manually turn on and off the note. Well, that's cool. think that's 0 again. So it sounds like there's not much... not much variability here on this one. Okay, well, I don't want to belabor this one too much, so let's go to the noise channel and see what we can do with that thing. Noise channel produces noise with a pseudo-random bit generator. It has a volume, an envelope, and a length counter. So let's reverse these changes we made, because we're just messing around here. It's okay that we get rid of this. So we're going to go back to what we were doing for the pulse. Okay, so we should be able to now switch to noise and get sort of a similar kind of effect because it has volume. It's 4-bit volume, so turn sound off. So yeah, so we're shifting all of that to, okay, that'll work. And that is, let's see, envelope, loop, length, counter, halt, constant volume, so those would be 0, and then volume envelope. Envelope, loop, length, counter, halt. So that's if we, I guess if we want to use the counter, and we don't want to use a constant, so it'd be 0, and then, so we just basically load our volume, and then, in fact, we don't even have to do that. We can just store it directly in, but not into that. We want to store that into 400C. I don't know. I have this habit of saying hex numbers like they're decimal, so 4000C. I don't know what other people do. Someone commented on one of my videos that I'm pronouncing the hex numbers wrong, and I should be saying 400C. So I don't know. It was never something that came up where at work we talked about hex all that much at any point, really. So it's not something that I feel like I've ever had anybody have a strong opinion on. The frequency of the noise is determined by the 4-bit value of 4000E. So, all right, so that's a little bit different than what we're doing for the frequency that we are setting for the pitch. You're holding it wrong. I don't even know myself. Yeah, I don't know. I don't know what... Maybe, Paul, you have an opinion since you're a hardware guy. I feel like hardware people have strong opinions on this kind of stuff, but maybe that's a software person's bias against hardware people. I don't know. We don't need to set the length counter load, but we do want the noise period. So the noise period, frequency of the noise is determined by 4-bit value, which performs period look. So let's take a look at how we determine the noise frequency. So we can actually just steal this, basically. Let's see what it says here. The timer period is set to the following rate. The 93 sequence is about quarter tone sharp relative to A440 tuning. The approximate frequencies are as follows. All right, well, we can just set a setting, right? So we'll say let's do 86. And I think, let me see what we're doing here. That would be on 400E, and then the load counter will just be 0. Let's see if we get any noise. Well, there was a blip of a noise there. Envelope loop length counter halt. Unused loop noise, which is what we're setting. So we're saying 400E is looping and the noise period is 6, and then the length is being set to 0. Do we need to set the length to anything? Let's change the frequency. Let's make it something, I don't know. Let's make it 81. Let's see what that sounds like. Maybe we do need to set that counter. Oh, it was just kind of like a beep. Let's see, 8F. Be interesting to see. Oh, that sounded kind of like a snare drum. All right, so the question is, why is that not playing over and over again? 400C. Is that the wrong register? No, that's the right register. That volume stuff should be okay. Maybe we do need to set the envelope loop. So it'd be bit 2. So I had removed this. Let's store this into temp 2. And then load A with 20 and OR it with temp 2, and then store that into there. Now that's cool. It's kind of got like a little groove going on just by itself. Okay. Let's see what happens if we mess with this. Let's, instead of storing 0 into it, let's store 80. Well, it's definitely making some interesting noises. I'm not sure that they're the noises that I was hoping to make, but it's kind of cool. So that stopped it from working all together. I imagine... Well, see, that's the thing. I was thinking that the volume would actually work the way that I expected, but it seems like it does not. And even setting with a constant volume, that's not working exactly. So if we go back to this, let's make it loop the... We're going to make it loop the noise period again. It doesn't seem to like that. If I just add something to, let's see, so the first 3 bits don't matter, so we'll make that 8 and we'll make that like 1. So I just set it to constant volume and envelope length counter halt. Let's see. Oh, there we go. That was more of what I was trying to do. Now let's try and figure out why that actually works. It's 4000 C. So 400E. So we're looping the noise and we're setting the period to F. And then we're putting a length of 1/8 hex. So if so what if we made this like F8? What would that change the sound to be? I think I understand what's going on here. But there's no difference in the way that works. Let's change this to different pitch. It's a sort of piercing high pitch noise. Oh, that's fancy. Can we mess with that and actually make it do something interesting? Or is it going to continue to just make that noise? See, what's weird about this... I thought what was happening was that we had to say that we wanted to loop because the period... Because otherwise the... Otherwise, it just kind of does a quick little blip. It doesn't actually loop the noise to produce the tone that you're looking for. What's weird, though, is that it also has a constant volume. I don't know why it needs that. Maybe I'm just misreading it. Maybe it's the opposite condition. Let's take a look. Length counter, constant volume flag. It doesn't really volume envelope divider. Mixer receives the current envelope volume except when bit 0 of the shift register is set. Or the length counter is 0. Well, the length counter isn't 0, is it? length counter load is set to 8, and then we had, so that's, gotta stretch this out so it actually formats properly. So we have this one bit set, and then we have nothing in the other bit. If we made this F, it's still doing the same behavior. 1 and 2, 4000 C. Oh, but you know what? We're not initializing. I guess that doesn't matter. It's weird that it's not dealing with the volume in the way that I expected, just simply like the way the pulse works, where setting these 4 bits to the pulse volume is all you have to do. It seems like mixer receives the current envelope volume. What does this bring us to? Okay. Except when bit 0 of the shift register is set, or the length counter is 0. So shift register, when power up shift register is loaded at the value of 1. When the timer clocks the shift register, the following actions occur in order feedback is calculated. The shift register is shifted right by 1 bit. Bit 14 leftmost bit is set to the feedback calculator earlier. Is there something else that's going on that I'm not just not following because I didn't read this carefully? Let's take a look at what our friend Brian came up with. I assume this is, it says this is from the Nerdy Nights, but it's in NES Dev. Okay, I guess they moved it over. Cool. Let's see. Does it have any examples? That's enabling and disabling channels. Load a ROM. Okay. Not as helpful as I wanted it to be. Have that. Have that. Let's see. So what are they doing with the noise here? So tone enabled. Huh? Come on. Okay, so that's the 8 and then 5. So that's that's what we're doing there. And then it's storing a volume, full volume with those 2 others. Interesting. The noise channel allows control over frequency, volume, and timbre. Well, so it sounds like, despite what I was thinking, those both have to be on for this to work in the way I was expecting it to, where you can hear it fading out every time it plays, which is fine. I mean, that's what I wanted it to do. I just, I'm trying to understand exactly why and how that all works. So if we change now, let's see, so this is the frequency. We change this to B. That's cool. How do we make it sound a little bit more like an actual, like a sort of softer... See, that's the thing. It's not really... That doesn't seem... This doesn't seem to be doing anything. F. One thing you may have issues later with APU is some of the functionalities are not really used since they're more cumbersome than anything. I don't remember which one, but someone once told me about that. Yeah, that's possible. I'm just trying to figure out how I can get something a little bit more like a very... well, what does this say? If bit 7 is of F00E is set, the period of the random bit generation is drastically shortened, producing a buzzing tone. The actual timbre depends on... Okay, so that's what they're saying, that if I make this 0, it shouldn't be as buzzy. Ah! Okay. So then if I make this, let's see. That's cool. That's more of what I was trying to make it do. And that sounds like an explosion. Yeah, I know, I'm just messing around with this. So what we could do, now that we have some things kind of working the way we expect it to, and kind of have a basic understanding, is it would be kind of cool to have, if we do, let's see, what is the pitch that I was liking here? We could do a, it'd be cool to do something where we have like a very basic, like a hi-hat type sound, and a couple of pitches playing together, and just like a repeat, a very simple repeating sound. There we go. That sounds kind of like a hi-hat. We just got to do a much shorter count. So 3C is 60. If we made it just 15, let's see if I can do this right without messing this up too badly. So that's 15, and then let's see, 255 minus, let's say 15 also, that's F0. Oh, 0F. Oh, the volume is not going to work anymore like that. Let's not do this. Sorry, thinking about this here. If it's 0, then it's going to reload the counter. Compared to 0. No, compared to F0. That's what I wanted to do. I reversed that. And we're just going to make the volume fixed. The volume will be fixed to like, let's make it 8. Sort of, that's kind of along the lines of what I was thinking. My math is just wrong here. So also pulse counter. Let's load pulse counter compared to F0. Branch if not equal. Decrement it again, and then we don't have to do that. We just do that, right? No, sorry. We do have to check it here. Branch carry set to this. And then what we can do is we can just flip the value of, we'll use pulse value like we were doing before. Load a pulse value, and no, what is that? That's not real. And then exclusive OR that and store that there, and then load a 38, no, 30, and then pulse value, and then store that, and then I gotta just recreate that because I undid that. See if we can get some. That's kind of cool. Not what I was trying to do here. Why am I having such a hard time with this? Pulse counter. Load a pulse counter compared to F0. Branch if not equal. If it is equal, then it's going to load 0F and store it into pulse counter. Let's do this. Let's do that there. So stores it, and then it will compare it to F0 if we've branch carry set. That means it is what? It would be carry is clear because F0 if F0 is less than it, then the carry would be set. And we want it to be clear. Load a pulse value, or store, and then you know, we're just going to keep it like that. It's not really even worth getting that far into because it sounds kind of cool. And we're just messing around right now. So, let's do this now. Let's go here, and in the triangle wave, we're going to put the bass note. Let me pause this for a second. So what we'll do is we'll load, and this would be what? We want to just stop the sound there when we press start. Okay, cool. Okay, so let's do this. Let's I'll just create a subroutine here called play music because I want to kind of keep this out of this main loop because we're kind of messing around with things and it's going to get messy. And then I just need to return. So, all right, so let's add some, we're calling that pulse counter and pulse value, but let's rename that to noise. Let's add a noise counter or noise value and switch those. We'll actually use pulse counter for the pulse. Oops. Okay, we're still getting our little groove there. Let's deal with the triangle, though, like I said, for the base. So this is pulse. Let's add another one called try counter. And, you know, this is obviously just totally random stuff I'm coming up with here, and who knows. This is probably all going to go away, but it'll just, this is kind of, like I said, more of a let's do something fun and not involving scrolling tonight, and then we'll worry about that later. Try counter, and then all right, so let's go back to our triangle wave. So same thing, we want to load our pitch into there, and I have a feeling the pitch is just controlled the same divide as is it the same? Unlike pulse, yeah. Frequency is the frequency of the CPU divided by 32 times tval plus 1. What's tval? Tval, value written timer high and low. So tval is the frequency of the CPU divided by 32 times the frequency minus 1, which I think in the pulse page they actually give you what that is, just to avoid having to recalculate it myself and do it wrong. Is that in the audio basics maybe? Yeah. All right, so let's make this in the key of A is boring because that's 440. Frequency of notes. Let's do it in, I don't know. Let's do it in B. So frequency of B is let's do a higher value of B. Let's say like B4. So 493. Uh, 394 minus 1. 2838. Right? Did I do that right? B4 is 493. It's 493 in a fraction. Let's, if we go to the standard calculator, we'll try and get as accurate a calculation here as possible. Divide by 111,860.8. Whoa, that was not right. I did that backwards. Divided by. And stuff like this, you'd have a lookup table for the notes. You wouldn't be recalculating this every time, but again, we're just kind of having fun tonight on this. So So 225.49, I'd say that's probably 226. So 226 is E2. All right, so let's do that. Let's set our frequencies up here. Set up noise, and then let's set up triangle. So we're going to load E2. E2, and we're going to store X into something. 400A. And then there's nothing for 400B. So 4008 is what we would need to set to turn it on. So let's just turn it on in here, and let's make sure that we've got a good pitch there. Nope. Oh, it's 1 and so first so 12. So C0. No. Length of, oh, we gotta set the length. No, yes we do, and we're not. Okay. Load X, let's just make this F0, because that was a good game for the Super Nintendo. 400B, alright. Alright, so now we've got a pitch that's playing in the triangle wave, so that's cool. So now let's make it so that we can turn that pitch on and off with the rhythm. All right. So we've got our triangle counter, right? Try counter. I can't spell. Try counter. Yes. And we initialize it there. And then let's see. So the value that we use for the triangle counter should be either, it should be C0, and then we'll flip those bits to make the sound turn on or off, alternating. So load A, C0, store A, try value, and then in our audio here, we're going to load a try value. We're going to decrement try counter. We'll load try counter, compare to 0. Or what am I doing? Branch not equal to this. So we set our noise. If it's 0, we're going to load try counter. No. Load A, 0F, store A, try counter to reset the counter. And then load try value and do an exclusive OR with C0 to flip the bits, and then store it back into try value. And should make it turn on and off. No, it just made it turn on. take a look at the code here and see what's going on. Probably just something silly. So it is counting as expected. And it's putting C0 into, oh, you know what it is? The problem is, I think I'm putting that into the wrong thing. Yeah, I'm changing the length, and that's not what I want to change. That's not even what I'm doing. All I need to do. Why was it doing C0? Now I've confused myself. Wait a second. It was 8-0 that I was doing, not C0. All right, so that was just a mistake. That's turning the counter on and off. So load try value store 4008. Oh, but I don't want to do that every cycle. That's the problem. I just want to do that when it changes. Because if you do it every cycle, then it doesn't actually get a chance to play tone. Yeah. 4000A gets the timer low, so that's right. And then this 4000B is getting the counter, which is for the F0. So that's fine. And then should just be resetting the counter. Linear controls will silence the channel after specified time with the resolution. Oh, maybe I need to reset the counter every time rather than turning it on and off. Let's do that. Hey Nikito, it's a vertical scrolling shooter. I'm messing around with audio today because for the last several weeks on stream and on recordings that I've done, I've been working on this scrolling stuff. So just figured I would work with something different instead of just continuing on with this, because it would be a little bit more fun to do something different. Yeah, so, and this for the original NES. All right, so turning it on is fine. I guess the counter is what I want to reload instead. Try value should just be F0 then. And what we'll do is once the once the counter runs out, it will reload that into 400B maybe? Let's see. I don't think that's going to yield quite the exact result that I wanted, but nope. This was so much easier when I was just trying to get one sound to play. Load a try counter branch not equal to there. Alright, so we're going to reset the counter, load the try value, sort it into 4000B. Let's comment this stuff out. Alright, we're not getting our steady tone anymore. Part of that is, I think, because we also... No, I've got that set. Linear counter load. Oh, that's 0, and that shouldn't be. Okay, so make that F. So 4008 is getting set to 8F. The timer is set in A, and then our length counter is being set in B. And are we messing with this at all here? We're not. So what gives? Expecting just a static tone here, but it seems not to be doing that. I had this working before. Triangle steps in 32, linear control silence. After specified time, which means they are always enabled at the same time, whichever is longer is redundant. It's only at a constant volume for the triangle. You can't change the volume. The pulses have volume, but the pulse and the noise have volume, but not the triangle. So just doing something silly here. Because this was working before. Oh. Store X, not A. Who knows what A is at that point? There we go. So we're getting a pitch there now. So now we want to actually turn some things on and off. Try value 4000B. So it's not resetting. Let's see what happens if we do this. Load title screen is... So we could do a couple of things. We're setting that to 0. If we set that to 0, I think it's going to stop all the pitches again. Yeah. So let's do this. Okay. So now that we have that playing a tone, right, so this is just resetting that tone over and over again, which is no good. All right, so we have the value, and then let's flip the bits. That should be, what, 8F, I think, is what we were setting it to. So we'll be swapping between 8F and 80. So E or F, exclusive or, let's do this like that and store it into try value. Sorry, I bumped the mic. Okay, so it's now running, but it sounds like it's doing it at a faster rate than the noise, which is likely because our noise is not exactly working the way I want it to anyway. So let's make this work the same way as the triangle is, because that's doing what I want it to, and we can just sort of replicate that. Nope, not try counter, noise counter, and then we'll exclusive OR it with some sort of value, and then store it back into noise value, and then forget this. Yeah, this is way more than I wanted to do with that. Whatever the E OR that we end up doing should be sufficient there, and then that's this, and then just load a noise value. Oh, but we don't want to do it every cycle. I just want to do it there. And now let's look at what that value actually has to be. Yeah, thanks. Yeah, I know. I saw that typo. You know, just moving fast and you type the wrong thing. Obviously. Okay. So 4000C was what I was modifying, which was the volume. So it was we had 3, and then let's just make the volume full. So we'll say it's just 0F there. So noise volume, or noise value, I should say. Load a 3F, store it into try value, noise value. Cool. So let's do this. I want to make the noise and the triangle alternate. So let's load 0 into try counter. I guess actually we need to load 1 into try counter, because it's going to subtract 1 and then it'll hit 0. Okay, so that gives us a little beat going on, and then we'll just maybe make it alternate thirds from, like, if this is B major, Do we want to do a major key or do we want to do a minor key? We could go from B to D, maybe a minor key. So from 493.88 to 587.33. So we have B already because we're setting that in our noise, sorry, on the triangle wave. So let's set up the pulse. We'll start with B as well. I think that's just in, what is that in? That'll be in 4002. And we'll keep the volume constant. Let's say we're just going to go with 0011 and then the volume. So load X, 0011 is 3, and then the volume is F. Store that into 4000. I don't know if I want to mess with the sweep and stuff like that. Let's go back to this APU basics here. And let's take a look at the example and just stick with that for now. It's not set at all. So that's fine. We'll leave that alone. So that's it. 4002 and 4000. 4003 doesn't have to get set because the pitch is not it doesn't span past the 1 byte. And then let's go to our pulse counter, and that will just alternate between 2 notes basically. So the value we want for the pulse value is going to be, we're going to have to, I guess, store the value of the note we're currently using, and if it's not, if we're changing, then we're going to switch to the other one. So the starting note we said was E2. So that's our starting value there. And then when we come into here, load pulse counter branch not equal to that. Reset the counter. You know what? Let's do a longer tone for the pulse. Instead of doing 15 frames, let's do 30. The other problem with what I'm doing here, if you're I don't know if you're like me and you're thinking about this, but it crossed my mind. Doing it this way will make the music slightly slower in PAL because the frame rate is 50 frames per second instead of 60. And so this would not play back at the same speed if we care about that. So whatever we do with audio, we probably want to make sure that we are not timing it purely to the frames like this. We would want to have some sort of counter that works a little bit independently so that we can time it to clock time, not just cycle count. But for the purposes of just what we're testing out here to mess around with it and have fun with it, it's okay. So our pulse counter is now set to 30 frames, so it'll play for half a second and pause for it'll play for half a second and switch notes. So load a pulse value, compare to, what did I say it was, E2? Yep. To E2, branch if not equal to there. So if it's not equal to E2, then we're going to load A with, we're going to load A with, we got to calculate what the value is. So the note for D is 587.33. Bonchaku. Yep, the engine is taking care of that one of many issues. Yeah, so again, another reason we might want to use a pre-made sound engine is that we don't have to worry about that difference in frequency for the music, because it will have done that. And I was at -1, I think. -1, and so as I get 189.45, let's call that 190, which is 190, which is BE in hex. So load BE and store it in pulse value, and store that into, where are we storing the frequency? 4002. And then if we are at, this branch of equal to, no, branch of, if it's equal, then, confusing myself. If it's already E2, we want to set it to be E. So if it's not equal, we'll go over here. Yeah, sorry. Sometimes doing this logic in assembly messes with my brain. Load E2, store in pulse value, and stored in 4002, and maybe we'll get the alternating pitch. Let's see. We get nothing. Are we not? Let's see. I guess just for kicks we can make sure to store something in 4003. 3. Oh, it's storing something different here. What is it store? It's storing 1011. So 8 and 3, that's 11. So BF. Okay. Guess that would matter. Okay, we have now a single pitch. So the question now becomes, what did I mess up with my logic that's causing it not to decrement pulse counter, load a pulse counter, branch if not equal to this. Otherwise it will load A with 1E. Oh. Store it into pulse value. Not load it into pulse value. No, pulse counter. That's what the problem was. Pulse value. Okay. Nope, that's not the only problem. Load A1E, stored into pulse counter, load pulse value, compared to E2. If it's not equal... Yeah, yeah, if it's not equal, then load that, store it into pulse value, put it into 4002, which should change the pitch. Oh. Jump to done. Helps if you don't keep resetting it. So, you know, now what we could do is we could do something with the triangle wave where we make it drop a third from B. What would that be? Would that be to G? I mean, that is a third, but I'm just thinking, is that the right pitch? Where's Family Tracker? I can type it by hand here if I'm remembering. I think I've got the right sound pitch in mind, but I instead of going through the trouble of doing this and then finding out I was wrong, where are my instruments? Family Tracker. That's not my desktop where I had put those. There. So if we have C, we're doing that, and then it's a minor third down. So that's what I was trying to figure out. So, oh, well, actually, was that C? What note was that? It's E. Let's. Oh, this is C. Okay, so G sharp. So yeah, minor third. So if we're on B and we're going to a minor third, we're going to G sharp. Is that going to sound right? One, two, three. So a major third is G sharp. Oh, my music theory is failing me. Okay, I think it's G. So what I wanted to do is I wanted to kind of give some variety to the triangle wave to make it a little more interesting. So, sorry, where did that go? G, that's 196. Oh, so that's easy to calculate. All right, let's go back to the calculation here. Getting, yeah, color doom quality, thanks. I didn't say this was the final music. This is just me, trying to do something cool. 392. I don't know where I got 196 from. Oh, because I was looking at the wrong one. G392, okay. So that's 284. So what I want to do is now make it so that we change the tone. And again, this is just totally not even how I would do this if I were building an actual sound engine, because you'd be data driven, not driven by these counters per se. But just for the sake of the fact that we're doing something super basic here. Let's see, so I want to count down how many notes we play before we switch. So if I go back to this, let's load a 08 to store that into try counter 2. All right, so now what we'll do similarly here is we will it's not 0, we go here. Otherwise, what we're going to do is we are going to, let's see, so the value for the triangle gets stored in 400A. I guess we'll just do duplicate of this. So yeah. 190 is, wait, that's not the, that wasn't the value, was it? Get out of here. Sorry, I lost the value. G4 is 392. Sorry, I'm recalculating this, but I lost it, and I really don't remember what it was. It was 284. So that's 1C. So that means it's got to fit into. We'll cheat. We'll cheat. We'll know that. We'll know that the value that we're doing is 1C, and we'll alternate it properly. I don't feel like dealing with multiple bytes for this. Okay, so it's going to start with that, and we can just kind of lift this code because it's the same idea. Actually, you know what? We want to steal the code from the pulse counter because that's more similar to what we're doing here. Counter 2. Oops. This. Try value 2. And this is try counter done. Try counter done. And we don't want to write it into there. We want to write it into 400A. And so if it's E2, then we switch to 1C, and we're going to have to store it not only into that, but we also have to load A with 1, oops, and store that into 400B because it's 1C, not just 1C. And then that's this, and then we're going to load 0 and store that into 400B because we want to go back to just E2. Load A1E. This should be 8 because we want to do it after 8 switches. Try value 2. Oh no, that's the that's the counter. Okay, that's right. That's right. Okay, let's see how that turned out. That should be interesting. Okay. Yeah, so we want to do this after every switch, not every cycle. And we got to double this because it is counting the off switches, which are incorrect. So we want that to be 16. So make that 1 0, and then this is 1 0. And the only other thing we got to do is make that 1 1 to account for the first cycle where it didn't play. There you go. Let's make the noise counter a little bit more rapid here because I want that to be more of like a kind of tick 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 kind of hi-hat counter. So it's the noise value. Where's the noise counter? Let's make that like, I don't know. So the other thing that's wrong with what I'm doing here, besides the fact that I'm hard-coding the music in like this, is that I'm also hard-coding in these values for the counters. These should be constants, so that I only have to change them in one place. But again, we're just messing with this. That's not bad. Probably want to do something. Counter's a little bit too fast now. Let's change the way the noise sounds a little bit. It's in the wrong place. It's the wrong thing, isn't it? I don't remember which one I want to change. Oh, it is that. What am I doing here? Noise counter 4. Okay. I don't want to change that. I want to change this. Let's see. So we got some sort of sound going here. Totally just hodgepodge together. Not at all something you'd want to ship the game with. Definitely probably has some weird issues with timing. Definitely won't work in PAL. In fact, I think you can simulate PAL in... yeah, hear that? Not only did it get slower, it got the pitch shifted down. And in games that are coded properly, that wouldn't happen. I don't know if I've got a game... I wonder if Castlevania actually did this correctly. Let's see. Nope. Well, so I don't feel so bad now. There's probably, you know what? There's probably a region version that plays it at the proper speed. So I shouldn't say that. They probably accounted for that in the one they shipped to Europe. But I know there are ways that you can. I think there are ways you can figure out what the cycle speed is and use that to determine how your game plays back audio. So the only thing we have left to do tonight before we wrap up, other than just completely get rid of this for now, just since this was for fun, is after we load new game, we got to turn off all the sound, because otherwise, well, let's... It just hangs like that because we're not reinitializing everything down to 0. So let's do this. The store A4000. Let's see. No, Triangle's still playing. Let's see why. What was I supposed to store in Triangle Wave to make it turn off? 40008. That's one too many zeros, probably. There we go. Now the music is off, and the game is playing as it should. At least as far as we are at this point. So, cool. That was fun. We got to explore how the audio stuff works and mess around with playing some sound back, and I don't know. It's just a kind of a fun experiment to do instead of dealing with attributes and scrolling like we have been for the past several weeks. So, as always, thank you for watching. Thanks for joining me on the live stream tonight. For those of you who did. As always, if you have questions, you can reach me on Twitter at Clearvis. Feel free to ask questions on the YouTube recording in the comments below. Definitely love hearing feedback from everybody or questions on things that could be clearer. You can reach me on Nintendo Age. I'm I'm Zelius. You can reach me on my email, where I am zelius@gmail.com. And as always, thank you and have a great weekend, and we'll catch you on Monday. Have a good night. Have a great weekend. Take care. Bye-bye.